Hello student, today I will explain you the architecture of distributed database management system. In my last video I have discussed client server system. Today in distributed Dbms architecture I will explain the second point, the second architecture, that is peer-to-peer distributed system. This is second model. So in peer-to-peer distributed system, the physical data organization on each machine may be and probably is different. Each machine may be and probably is different. This means that there need to be an individual internal schema definition at each site, which we call the local internal schema, that is also LIS, in short we can say. The enterprise view of the data is described by the global conceptual schema, that is denoted with GCS, which is global because it describes the logical structure of the data at all the sites. Here, data in a distributed database is usually fragmented and replicated. To handle this phenomenon of fragmentation and replication, the logical organization of data at each site need to be described. Therefore, there need to be a third layer in the architecture, that is the local conceptual schema, LCS, we denote by this. In the architecture model, we have chosen then the global conceptual schema is the union of the local conceptual schema. So finally, user application and user access to the database is supported by the external schema, which is denoted with ES. Defined as being above the global conceptual schema. This architecture model, that is peer-to-peer distributed database architecture model, which is given as shown below, provide the level of transparency. Data independence is supported since the model is an extension of ANSI Spark, which provide such independence naturally. Location and application transparencies are supported by the definition of local and global conceptual schema and the mapping in between. Network transparency, on the other hand, is supported by the definition of global conceptual schema. The distributed DBMS translate global queries into a group of local queries, which are executed by distributed DBMS component at different sites that communicate with one another. Here you can see how peer-to-peer distributed system work. The first one is external schema. The second one, LCS, that denotes local conceptual schema. And the last one is internal schema. it all work just like client to server, server to client. Now, in terms of the detailed functional description of our model, the ANSI Spark model is extended by the addition of a global directory, or you can also say dictionary, which is denoted by GD/D, that permit the required global mapping. The local mapping are still performed by a local directory, which is denoted with LD/D. Thus the local database management components are integrated by means of global Dbms functions. From the above figure, this is this figure which I am showing you. Here the local conceptual schema are mapping of the global schema on each site. Furthermore, such databases are typically designed in a top-down fashion, and therefore all external view definitions are made globally. A local database administrator at each site. At each site. The existing of such role may be controversial. However, we should know that one of the primary motivation of the distributed processing is the desire to have local control over the administration of data. Now, from this figure of peer-to-peer distributed system, the detailed component of a distributed DBMS, which is given here, one component handles the interaction with the user and another deal with the storage. It is divided into actual two parts. That is one for user processor, and second one is data processor. The first major component, which we call the user processor, consists of 4 elements. Number 1, user interface handler. Here, the user interface handler is responsible for interpreting user commands as they come in and formatting the result data as it is sent to the user. The second point is semantic data control. It uses the integrity constraint and authorizations that are defined as a part of global conceptual schema to check if the user query can be processed. Now, in third, global query optimizer and decomposer. Here, it determines an execution strategy to minimize a cost functions and translate the global queries into local one using the global and local conceptual schema as well as the global directory. The global query optimizer is responsible, among other things, for generating the best strategy to execute distribution join operations. And in the last, distributed execution monitor. These are the 4 parts of user processor. This is the last one. Here it coordinate the distributed execution monitor coordinate the distributed execution of the user request. The execution monitor is also called distributed transaction manager. In executing queries in distributed fashion, the execution monitor at various sites may and usually do communicate with one another. So these are the 4 points of user processor. Now, Data processor. Again, in data processor, the second major component of distributed Dbms is data processor that consists of three elements. The first one is local query optimizer. In local query optimizer, here which actually acts as the processor path selector, is responsible for choosing the best access path to access any data item. Best path it chooses. The second one is local recovery manager. It is responsible for making sure that the local database remain consistent even when failure occurs. Local recovery manager, it is responsible for making sure that the local database remain consistent even when the failure occur. And the last point, runtime support processor, it physically accesses the database according to the physical command in the schedule generated by the query optimizer. The runtime support processor is therefore to the operating system and contain the database buffer manager, which is responsible for maintaining the main memory buffer and managing the data access. So these are the 3 points of data processor. Here we distributed data part. Database system is divided into 2 parts, that was user processor and data processors. Now finally, in the peer-to-peer system, one expects to find both the user processor models and the data processor models on each machine. In peer-to-peer system, one expects to find both the user processor model and data processor model on each system. These two processors should be on each system. However, there have been suggestions to separate query-only site in a system from full functionally ones. In this case, the former site would only need to have the user processor. Thank you for watching my video lecture. Hope you all understand. Thank you.